But the fact is that you'll probably see it again. You'll probably get asked for possible rational zeros. I mean, in this class, I could tell you that when we get the test from downtown, like for the 9-week or semester exams and things like that, they always put something like this on there. Okay. And I just gave you an example, right? I put a 4th degree, but it could be any degree of a polynomial, right? If there's a list of, if there are rational zeros, which doesn't have to be the case, but if there are zeros which are fractions or integers, they have to be of the form of the factors of the constant divided by the factors of the first coefficient. So that's why the E is the last number and the A is the first number. They have to be in the list of all of those possibilities. That's called a rational zero test. And there are things that I took out of the section because I do think that they're really just, nobody would do that anymore, for sure. Yeah. If you don't see it quite yet, wait till the next slide where you see an example of it, and it'll probably make more sense when you see that. Okay. We all right with that? Julia, you almost done? Okay. Can I go? So, for example, if I'm going to find the possible rational zeros of this polynomial, then it would have to be the factors. I need to make a list of the factors of 3, the last number, and divide it by a list of the factors of 2, the first number. So you just got to say to yourself, what are the factors of 3? It's 1 times 3. But it's also negative 1 times negative 3, right? So whenever you come up with your list, it's always plus or minus, always plus or minus. So we would have to say plus or minus 1, plus or minus 3, right? In the same way, then, what would you say are the factors of 2? Plus or minus 1, plus or minus 2. Okay, so the possible rational zeros are going to be some combination of the factors in the numerator divided by the factors in the denominator, right? Possible rational zeros. So just take all the combinations you can, right? So I could say like 1 over 1 is 1, so plus or minus 1. 1 over 2 is 1/2, so that's plus or minus 1/2. 3 over 1 is 3, so plus or minus 3. And then 3 over 2 is 3/2, so plus or minus 3/2. So how many possible rational zeros do we have in our list? We have 8. How many possible rational zeros do we have? I mean, how many actual real zeros could we have? 3. You couldn't have any more than 3 because it's 3rd degree polynomial. So these are not all going to work. And it doesn't even mean that there are any. They could all be irrational or they could be imaginary, right? It's just possible. And in the old days, like I said, when I was young, when we didn't have a graphing calculator, you would probably have started with that list and then just started doing synthetic division 8 times until you found what worked. Yeah, or plug them in and see which one leads to a 0, and then use synthetic division to reduce, right? So that was the strategy. These days, that's probably not what we're going to do, right? So let me do this.